Okay, so in the top box where it says quick notes, that's exactly what we're going to do right here. We're going to take a few quick notes about the graphs of trig functions. Okay, pause. I'm not pausing. Oh, okay, play. All right. So this works for either sine or cosine. Okay, so understand that we can interchange. I'm writing right here y equals a sine of b times x minus c, close parentheses, plus d. This is a sine curve with a bunch of different parameters. X minus c, right? So these could be lots of different things, parameters, lots of different transformations on a sine curve. Understand that this could interchange cosine as well, okay? Both of these transformations work for, or all of these transformations hold true for both functions. Okay, these functions are called sinusoids or sinusoidal functions. Sinusoidal functions. So if someone asks you, hey, what'd you do today? You just tell them, I graphed sinusoids. And that makes you sound really something. I don't know if it's intelligent or sinusoidal, not sinusoidal, it feels like. Sinusoidal functions or sinusoid. Dinosaur. Moving on. So this value A, this is in front of the entire function. It's kind of a coefficient, if you will. This is responsible for the vertical dilation. I kind of prefer what he's saying about dilation. You could call it the stretch or the shrink, right? Vertical stretch or shrink. I like what he said with dilation because that kind of holds true both ways. Understand that if that number is larger than 1, it's going to get taller. If that number is less than 1, it's going to get shorter. Also, if that number is negative, what does it do? It reflects. Good. And so we say that the amplitude is the absolute value of A. Okay, so if that's a negative 5, I know that my distance from the midline to the peak is 5. Even if it's reflected, right? So the absolute value, that handles the fact that it could be flipped, but A is still amplitude. Okay? And in terms of the circle, Truett, that's your radius. That's what you were saying yesterday. If the radius is larger, then it changes the way that the function is laid out as far as its height. Okay, so letter B. Letter B. B is inside the argument. B is a multiplier in the argument. Because it's inside with X, I know it's the horizontal dilation. It's going to be a shrink, meaning it gets smaller if B is greater than 1. Because insiders lie. If this feels backwards to you, it's because it is. If B is greater than 1, it's a horizontal shrink, horizontal compression. Okay? And then horizontal stretch. If B is between 0 and 1. Name that kind of number, Ruth.
Between 0 and 1.
What kind of number? A fraction or a decimal? Okay. No, what kind of number is between 0 and 1? Good. No, she said 0.5. Okay, so here's how we calculate what that looks like. We say that the period of these functions, period should be 2 pi. Yeah? So we actually find the period by doing 2 pi divided by b, divided by the number that we're seeing in that b position. Is that what you were going to ask?
Yeah. So if it shrinks, then the period would get shorter.
So I'm going to teach you in physics, we'll talk about something called frequency. Period and frequency are inversely related. So if I'm decreasing the period, I'm shortening it. Now I'm saying that I'm increasing the number of cycles or the frequency that could happen, over that period of time. Yeah. So those are inverses, and that will make more sense to you when we start our oscillations unit in physics. Hang tight. We'll get there. Okay, cool. Next, C. C. What is C responsible for?
Shift.
Horizontal shift. Good. Horizontal shift. It's like a phase shift. Left, right. Left, right. And you just keep in mind that insiders lie. This is located in the parentheses with the x value. So insiders lie. So if it's x minus c, it's going to go to the right. If it's x plus c, left. Okay. Which is kind of hard to see because these functions oscillate. So it's very difficult. And then D, what's D going to be located for? Or responsible for? Yeah, it's your vertical shift. Outsiders tell the... So it's going to really tell the right story here. Up and down. This affects what? Oh, she's doing like this. Everybody look. What does it affect?
Amplitude?
Not amplitude. That would be like this. What's it affecting? What's the word? Range. Range. Where it's located. So if we if we shift it up, we shifted the whole function up. So now it's not oscillating between -1 and 1. Now it could be oscillating between 1 and 2. Okay? So affects the range. That vertical shift, K, that can do a lot of damage to the range. Why is what? Oh, affect, because it's a verb. Affects, not effect. It's not the effect it has. It is the how it affects the graph. I know this. This is English. Affect. It's a verb. It affects the range. What effect does it have on the range? That would be an E. Come back for more grammar. Me, I'm the dude. Ah.
That's incorrect grammar. Me, I'm the dude. No.
All right, here we go. Graph y equals -3 cosine x. So what do we know?
It's a cosine.
It's a cosine. So technically it should start at 1. But it's flipped. So instead it's going to go through -1. So everything here is upside downwards. It should go through pi over 2 comma 0. That's still 0. Should go through pi comma 1 if it's upside down. Right? I kind of like to map out what I thought it was going to do. You understand what I'm saying? No, bad. Instead, though, instead of doing like this, it's stretched by a factor of 3. So instead of going through 0, -1, it's going to go through 0, -3. And instead of pi being at 1, it's going to be up to 1, 2, 3. So I think it's going to look more like this.
Is that the door?
Anybody see AirPods? Probably looking right around where Carson is. Anybody see AirPods left in here? Uh-huh. Looks pretty parabolic. I can see that until what? Yeah, until it goes on the other side. If we continued it, we would have... Now it's not parabolic. Any questions on that? Amplitude. So it flipped. Amplitude was -3. So it stretched by a factor of 3 and it flipped. Let's do the next one. This one says graph y equals 2 times sine of x minus pi over 2. So I'm going to take my sine curve, which should go through 0, 0, and I'm going to scoot it where? No, x minus pi over 2. Right 2. So now it's starting here. Sine of pi over 2 is going to be 0. Everything's going to add to the right. Okay, what is sine of pi over 2 normally? Say it louder, you're right. 1. So sine of pi is going to be 1. Go with me? Okay, I'm going to stretch mine in a minute. I'm just translating right now first. What's sine of 3 pi over 2 normally? Supposed to be -1. Now that shifted to 2 pi. What's sine of pi normally? Say it louder. You're right. Rosalind said 0. Sine of pi is 0. So we're switching that over to be 3 pi over 2. So this is my sine curve moved over, shifted to the right by pi over 2. Do y'all see that? Now we need to stretch it. No? Really no? Or just kind of no? What was it supposed to look like? A regular, typical sine curve? It looks like this.
You did like 2 spaces in that one.
Yeah, you already stretched it. Like
I did?
yeah,
Oh.
If we
subconscious.
that's why I was saying you don't need to.
I don't need to stretch it anymore. I already did that. I've been this way all day long, y'all. Okay, so this is what it's supposed to look like. Our transformation, which has already been stretched by a factor of 2, looks like this. Nikki's at home. He's going to be trying to figure this out. Nikki, I'm not crazy. It's your medicine. Poor Nikki. He's sick. He's on.
And David.
He's on. David too. I sent them both home yesterday.
Mm-hmm.
Guys, take more NyQuil. It'll be fine. Okay.
Or Dayquil.
Determine the domain, range, period, and amplitude of this function. So let's talk domain. We know the domain on a sinusoid is always all real numbers. We have yet to see that change. So our domain here is going to be all real numbers. It's going from -infinity to +infinity. I'm saying that it hasn't changed. So on sinusoids, no.
Okay.
No. Range, well, that k value at the end over here plus d or plus k, that has an effect, EFF, effect on range. So now we've shifted up 2. And the amplitude here is, let's go ahead and nail that number down. What's the amplitude? 5. It's a vertical stretch of 5 based on that 5 right there. Can you see it?
And that's always going to be positive, right? Instead of absolute.
Right, absolute value. So here's the deal. Amplitude is distance from the midline. Now the midline is at 2. The midline has gone from the x-axis up 2 clicks. Amplitude is distance from the midline. So my maximum value is going to be now at 7. And my minimum value is going to be now at, so what's my range?
-3 to 7.
Now you see? -3 to 7. Good. Period. Supposed to be 2 pi.
No, it's 2 pi, I think. Oh, wait. Would it just be pi? Yes, it would just be pi.
It's an insider's lie. So a half period, or the half multiplier, is actually double. So now my period is 4 pi. Insider's lie. Remember, I can take that period, which is supposed to be 2 pi, and I can divide by that coefficient, divided by half. 2 pi divided by half is 2 pi times 2. So I get 4 pi.
Yeah.
Yeah? Okay. Number 3. An equation for the graph below is given by y equals a sine of bx plus c. Find the values of a, b, and c. Okay, it's shifted down. How many? Your midline has gone from 0 to -1. So it feels like c is -1. That's the midline. Yeah, it says y equals a sine of bx plus c. Mm-hmm.
So we can cancel out cosine.
That's number 4.
Oh, my bad.
What's your amplitude, your distance from the midline to the peak? Is it 0.5? Okay. And B, what's the period here? You can measure from crest to crest. You could measure from trough to trough. You could measure from intersection to intersection. Still 2 pi. So what's your B value if that has not changed?
1.
B is 1. Good.
This will be 0.5.
Nice job, y'all. Are we okay here?
So would it be 0.5 sine of x minus 1?
That's what you.
Uh-huh.
You would like that.
Uh-huh.
I was looking wrong.
Yeah, true. It said, so would it be 0.5 sine of x minus 1? Yes, I believe this is that picture. Good. Okay, last question. Which of the following is not equivalent to the other 3?
What?
Let's look at A. Let's graph it. Cosine of x plus pi over 2. So what that means is I'm scooting my cosine function back a pi over 2 to the left. Letter B says sine of negative x, which is going to be a reflection of sine about the y-axis. Actually plays much like a reflection of sine about the x-axis. Still looks like this. C says, hey, take your sine curve and scoot it back a whole pi, which would make it, if I scoot scoot it forward, scoot sine forward. So instead of going through here, it's going to go through here, right? So now this looks like the other ones. Yeah. What does D look like? Negative cosine. It's not a sine curve.
I don't know, but like.
It's so hard to tell. Does it matter? No. Because it's half a period. So if I shifted forward or shifted backwards, it's going to be the same. So I'm taking this point and I'm moving it. So sine is supposed to look like this. I'm going to move that to here. Now look. So hard to tell. So I would say D is your right answer here.
Would they have questions where you have to guess?
I'm going to guess not. I'm going to think that they're way ahead of that.
That would be really bad.
Really, really bad. Okay, so use this information, get with a partner or a group, however y'all want to work together, and work through the circuit that I gave you on trig graph transformations.
Is Megan dead?
I don't think so.
I really think